Alright, so let's start on these solutions. The first question is this cooling question, and it's 10 degrees Fahrenheit outside. Your coffee is 150 degrees. You're going to use this 5 minutes here in a little while. And I give you a K value, which describes the properties of the disposable coffee cup that you picked up. So Newton's law of cooling says that the rate of change of temperature is directly proportional to the difference between the ambient temperature and the temperature of the object you're interested in. You know, if you think about this as delta T, then the temperature changes depending on how different it is from the surroundings. Right? And this is the time varying temp of the object of interest. So for our case, that means that dt equals, I gave you this value, it's in reciprocal minutes, and then the ambient temperature is 10 degrees. We don't know the temperature of our coffee cup. It's changing. So we can solve this with separation of variables. So anyway, and also the initial value is 150 degrees Fahrenheit. So this constitutes what I wanted for A. For B, we're going to separate. So dt over 10 minus t equals 0.025 dt. Integrate. It's going to be minus ln, absolute value of 10 minus t, equals 0.025 t plus a constant. Multiply both sides by that minus sign. Notice I just kept it as plus c. Exponentiate. So this is going to be e to the minus all this stuff, which we'll rewrite as e to the c, e to the minus stuff. Take off the absolute values. Now it's plus or minus e to the c, e to the stuff. This we'll call a. It's just a non-zero constant. Solving for t, we'll have t minus a e to the minus stuff equals our function. This is our general solution. To find our specific solution, we need to use our initial value. So t of 0 equals 150 degrees equals 10 minus a. So a equals minus 140. So then our particular solution is 10 plus 140 e to the minus 0.025 t. So that gives us the answer to B. And then C, what is the temperature of the coffee after 5 minutes? So this is 10 plus 140 e to the minus 0.025, and this will end up being equal to about 133.5 degrees. Alright, so that's the first question.